Hey guys, today we're going to continue on with the exponential function, but we're going to be talking about exponential function applications, okay? So we're going to talk about ways that we can actually apply it. Some of these are very silly examples, but I do hope that you see how it really is used in the real world, alright? So let's start with number one. The buzz bugs are loose. Somehow 3 bugs manage to escape and are populating your neighborhood. The buzz bugs double in population every day. Write an equation in the form y equals a b to the x that represents the population of bugs after a certain number of days. Okay, so first off, it says after a certain number of days. Alright, so that's going to be your x. So we want to leave x as x. So basically what it's saying is we want to fill in a and b. A, for most exponential situations, a represents your starting amount. B is the rate at which you are increasing. Okay, and you can see this on the formulas page. I didn't bring one up. I'll stop this video in a second. I'll bring one up. But you can see this on the formulas page. Alright. So then what would be A for this problem? Well, what was the starting amount of bugs for this problem? 3. So y equals 3 times, okay, B. B represents the rate at which you're changing. What is the rate I'm changing? I'm doubling in population every day. That means I'm going by 2 raised to the x. Bam. That's what it's talking about. Y equals 3 times 2 raised to the x. That's our equation. Use your equation to predict the number of bugs after 8 days. Great. Which variable represented days? X did. So we just want to know what is y equals 3 times 2 raised to the 8th power. We just want to know what is that answer. Not hard. We can cheat and use our calculator to do that. Okay. 3 times 2 raised to the 8th power. Press enter, and we get 768. My goodness, that's a lot of bugs. That's how mosquitoes are all the time. Alright. So, after 3 days, not after 3 days, I'm sorry, after 8 days, 3 bugs turn into 768 bugs. Okay? Next question. How long will it take the buzz bugs to be more than 3,000 in number? Okay. There is a way you can do this with a calculator, okay? And I want to show you that way today, okay? So, what we're going to do is we're going to go to y equals of our equation. And what we're going to do is we're going to say 3 times 2. Oh, I didn't get the 3 in there, did I? 3 times 2 raised to the x. Now, go to the table. And what is the question? How long would be more than 3,000 in numbers? Guys, I'm not looking for a precise date here. An approximation is going to be completely okay. So just go down until you see yourself become more than 3,000. I'm not there yet. If my thing would hurry up. There we go. Look, 3,072. On what x value was that? 10. And what did x represent? Days. So it took about 10 days. Okay. What is the coordinate of the y-intercept of this function? What information does the y-intercept give you? Okay, so first off, what is the coordinate of the y-intercept? What does y-intercept mean? It's where I cross the y-axis. What do I know x is always when I cross the y-axis? 0, that's right. I know that x is 0. So this question is basically saying, hey, what is the value you get when x is 0? Well, look, we already have the table pulled up. Let's just not make our life hard. Let's just scroll up here real fast. There are several ways you could do this part. But, basically, at the end of the day, you need to know when x is 0, what is y? 3. So, what is the coordinate of the y-intercept? It is at 0, 3. What information does the y give you? Well, guys, think about this. When you have 0 days, how many bugs did you have? 3. So, the y-intercept is your starting amount. The y-intercept is your starting, you could say it is your a value. Okay? It is just simply your starting amount, or it's your a value. Okay? Don't worry about it. Well, what is a reasonable domain? Okay, this is exponential. We talked about this yesterday. Alright? It's negative infinity to positive infinity. Except, can you ever have a negative amount of bugs? Just think about that for a second. Can you ever have a negative amount of bugs? No. So, in other words, your starting amount of bugs would have to be 0. But I really can keep going on forever with bugs for forever. So, 0 to infinity. And what about range? Okay? Well, what did range represent? Okay, I'm sorry. When I did domain here, no, I did that right. No, I didn't. I'm sorry. I said I approached domain, but I called domain bugs. That's not true, is it? What did x represent? A represented after a certain number of days. Okay? So the question I should have asked, it won't change my answer. The question I should have asked is, can you ever have a negative amount of days? The answer would be no. You can have 0 days, okay? But you can't have a negative amount of days. So it doesn't change my answer, but I phrased it wrong. Now, range is number of bugs. And I would ask you again, can you have a negative number of bugs? No. But what was my starting number of bugs? 3. So I would just say from 3 to infinity. Okay? I apologize for that. All right, let's move on to our next example. Oh, no, I clicked clear objects. I don't know what that did. Okay, next example. The population of a certain town is around 25,000. However, the number of citizens is projected to increase about 8% every year. What will be the population in 4 years? Here's where I suggest using the formula page. So let's look at the formula page. So, you see, guys, see this one? Item increased by a certain percent each year. Okay, well, let's go back to the question. The population of a certain town is around 25,000. However, the number of citizens projected to increase by 8% every year. So it looks like the item in this case would be the number of citizens. And it seems like it's going to go up every year. So this is a perfect candidate for that problem. So let's talk about that formula real fast. Okay? So item increased by a certain percent each year. It says y equals A times 1 plus R to the T. Okay. A, right here, is your starting amount, just like it always was. R is your rate of change, just like B was. Okay? More or less. Okay? And then T is just your time. Alright? So, I clicked on the wrong file. So for this problem, it says the population is around 25,000. However, the number of citizens is projected to increase by 8% every year. What will the population be in 4 years? So this is a simple y equals 25,000, that's my starting amount, times 1 plus 0.08 raised to the 4th power, because that's the total number of years. So we're just going to plug this guy in a calculator, and we're going to have our answer. Okay? So we're going to go second quit. Oh, we're going to go to 25,000 times 1 plus 0.08 raised to the 4th power. And we get 34,012 people. Now, why am I not rounding to other numbers? Why am I not, using decimals? Because we're talking about people. You can't have part of a person. Okay? So, 34,012 people is the correct answer. All right? A manufacturing plant sends 50,000 cubic feet of CO2 into the atmosphere annually, but has signed an environmental agreement to cut these emissions by 12% each year. To cut, what does that mean? Does that mean to go down or up? That's right, to decrease. To what level will the carbon emissions drop in 4 years? Guys, this is a perfect situation for the formula right here. Item decreased by a certain percent each year. So instead of just saying 1 plus R, it's just simply 1 minus R. So we're just going to say 50,000, because that's my initial amount, times 1 minus 0.12 raised to the 4th power. Okay, so we're going to grab our calculator, which is just going to be 50,000 times 1 minus 0.12 raised to the 4th power. And that gives us 29,984.768. Okay, and you'll notice I am going to include decimals, mainly because that is something that you can have part of, okay? It makes sense to say you have part of a CO2 emission, all right? Because it's just a type of gas, unless I'm terribly wrong. Pretty sure it's just a type of gas, okay? And so you can have part of a gas. So 29,984.768. And it's about. That's what I'm trying to do the about because I'm rounding. Well, actually, I guess I didn't round on this problem. All right. Next problem. An investment of $7,000 is made in an account with a 4% interest rate that is compounded monthly. That's important, compounded monthly. How much will the account be in after 3 years? Go look at your formula page. What do you see right here? When annual interest compounds more than once a year. So this is the formula we want right here. Okay, P is it's just a fancy finance term. It's called principal. It's just your starting amount. That's all it means, okay? P is just your A, all right? It's just your starting amount. R is just your rate of change, just like we've been talking about. N is just simply the number of times you compound every year. And this is raised to the n times t. T is just a number of years. So when we go to this problem, we say, okay, I have $7,000 in my bank account right now, times 1 plus R is your rate of change. What was my rate of change? My interest rate, 4%, so that'd be 0.04, divided by, how many times am I compounding? Monthly. How many times does that mean I'm going to compound in a year? 12. That's correct. Raised to the, how many times a year? 3. That's right. So now we just jab all this in the calculator and we're ready to rock and roll. So 7,000 times 1 plus 0.04 divided by 12 raised to the third power. We press enter and we get 770.23. So if you have an interest rate that compounds, if you have an interest rate of 4% and your investment compounds every month, okay? And my understanding of the word compound is just this idea that basically it like redoes that interest rate, okay? It looks at the end of the month and then it applies that part of that interest rate. Now, obviously, it's not the whole interest rate because that interest rate is throughout over a year's period, okay? So it's part of that interest rate, hence the 0.04 divided by 12. All right? And so, but after 1 year, you would have $7,070.23. So that means after 3 years, sorry, not 1 year, after 3 years. So that means that if you invested $7,000 at 4% that compounded monthly, you would have gained $70.23 without adding anything more. All right, let's go to our next problem. The formula Cm is equal to 500 times 0.95 raised to the m gives the cost C of a gaming system after m months. What was the original cost of the gaming system? Okay, guys, where has our starting amount always been? The beginning, 500. So the original cost was 500. How many months did it take before the price of the game system fell to $200? Okay, we do not need to make this hard. How did we do this when we did this on problem 1? How did I find the input value when I was given an output value? That's right. I just simply plugged it. Oh, not there. I just simply plugged into my y equals. So I'll do that again. I'll go here. I'll say 500 times 0.95 raised to the x. And then I'll go to the table. This time, what's my output value? 200. I just want to know how many months did it take for it to fall until it was less than $200 or to $200. And you can approximate. I'm not concerned. It took about 18 months. And that's fine with me. We're just going to approximate that it was 18 months. Okay? What was the cost of the game system after 2 years? Okay, since we're already here, yes, guys, you know what you could do? You could change 2 years to months and plug in it. But since we're already here, what is 2 years in months? How many months is in 2 years? 24. So we're going to go down to 24 and just see what the game system costs. The game system cost $145.99. So after 2 years, the game system that originally costed $500 now costs $145.99. And that's always why you wait for Black Friday sales after something's been out even for a year or so. Because it's so much cheaper. Alright, next problem. Problem number 6. The population of a country increases continuously, hint, 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 continuously with a rate of 8%. If the current population is 800,000, what will the population be in 5.5 years? Well, let's go back and look at our formulas. Do one of these formulas talk about continuously? When change is natural or continuous. This is the bad boy we want right here. Y equals P times E raised to the RT. P is just your principal. It's just your starting amount, okay? E is your natural number. It's found in your calculator, second division, okay? R is just your rate of change that we've had, okay? And T is just your time in years, okay? So my starting amount for this problem was 800,000. 2, 3 times E raised to the, okay, my rate of change is 8%, so that's 0.08 times 5.5. Alright, so you just take this, you plug this bad boy into a calculator. 800,000, so there you go. Second division sign. Oh, actually, let me put this in parentheses just to be safe. Second division sign raised to the 0.08 times 5.5. Press enter, and we get 4,766,463, and it looks to be 10 cents. All right, that is not money. I made that up. That's how many people they're going to have 5.5 years. They're going to have 4 million, so I would not include those decimals. This is not talking about money. We are talking about people. All right, it had a huge growth, 8% every year, and it was continuous, which makes sense. It's people. People, you know, don't get birthed at specific rates. They get birthed all the time. So that's why we use the continuous model there rather than the one we used above. It really makes more sense to use the continuous model. Okay? Let's go to our next problem. A radioactive substance loses half its mass over a 6-year period, or its half-life is 6 years. For example, a 1,200-gram sample will decay into a 600-gram sample after 6 years. So that's why its half-life is 6 years, because every 6 years it's now half of what it was. Okay, write an equation for this situation. Okay, so looking at problem 7, what was our starting amount? 1,200. That's right. Okay, what was the rate of change? That's right, I got halved, right? So 0.5. And then raised to the x, the number of years. Okay. Let's pause on that problem. Hold on. Something's bothering me. Oh, I'm forgetting to include the idea of its half-life, which is 6 years. So you take the time, that would be x. I labeled x. You could put a t, and you divide it by its half-life, which would be 6. Okay. And actually, I'm pretty sure we have a formula for that. Yeah, right here, half-life formula. A, that's just the original amount, times 0.5 raised to the t, the number of years, divided by h, which is the half-life. Okay, which is, this fits. 1,200 was my original amount, 0.5 for the fact that it's half-life, raised to the x, number of years, divided by 6. So you could say t instead of x, that's fine. Alright, how much substance will you have in 12 years? Okay, just plug in our 12 right there. Alright, so we can just simply say 1,200 times 0.5 raised to the, ooh, I messed that up, didn't I? 1,200 times 0.5 raised to the 12 divided by 6. Press enter, and we get 300. So, after 12 years, I will have 300 grams. Alright, of this radioactive substance. For what interval of time will the amount of substance be greater than 400? You know, just don't worry about C. It's a weird way of phrasing a question. I don't care about it. Just don't worry about C. Okay? Moving on. Also, because this video is taking a long time. When a certain drug enters the bloodstream, it gradually dilutes, decreasing exponentially. Okay? With a half-life of 3 days. Okay, so it has a half-life, guys. If the initial amount of drug in the bloodstream is 300 milligrams, what will be the amount 30 days later? So first, I need to create my formula. So what is my half-life formula? Well, you take your starting amount, okay, the initial amount, which was 300, you say times 0.5, raised to the t, the number of years. Ooh, this is a hard problem for that reason. But, and I'll talk about that, t divided by its half-life, which is 3 days. Okay. And I believe half-life should also be in years. Actually, no. T in this case does not have to represent years because my H is not going to be in years, okay? Since T is going to be in days, all right, because T says what will be the amount 30 days later. So I'm going to plug in a days for T, and I'm also going to plug in a days for H because that's my half-life with a half-life of 3 days. Since both T and H are both going to be in days, that's fine. Okay, you just can't have them. One couldn't be years and the other one in days. All right, they have to maintain the exact same type of unit. So in other words, if one was months, the other one would need to be in months. If one was in years, the other one would need to be in years. And you know, if one's in days, as long as the other one's in days, no special work has to be done. So this is our formula, and now we're just going to plug in 30 for T. So we're just going to simply say 300 times 0.5 raised to the 30 divided by 3. I apologize for that confusion, guys. So we press enter, and we get 0.29. I'm just rounding. Alright, what will be the amount 30 days later? It'll be about 0.29 milligrams. Alright, 10 grams of uranium will decay to 2.3 grams in 510 years. What is the half-life of uranium? Okay, this is a good question, but honestly we're out of time and we're never going to test you on a question like this. So I encourage you guys, if you really like this kind of stuff, see if you can't stop and figure that out. But for the sake of our time, this video is already 21 minutes long. Don't worry about 9 and 10. And I'll also send out, if I need to remove any of the homework questions, I'll make sure I let you know. Alright guys, I hope you have a good day. I hope this kind of made sense. Let me know if you have any questions. Alright, yeah, just send me a reminder or an email with any questions.